All right, everybody. So today we are back in action and we are talking about how to create customer insights, customer insights, or just create insights about the customers in your database. Okay, so how can we get more interesting, more useful information and thereby satisfy our customers to a greater extent? That's what we're going to look at. And there's all different ways to do this. You can do demographic analysis, churn analysis. I have a video on that, so I'm not going to repeat myself here. Revenue contributions, channel performance, regional insights, right, across different parts of the country. How is your business performing with customers? How do they interact with you? Things like that. Um, Churn prediction, pretty similar to churn analysis. I've already done that video. Customer satisfaction analysis, I have a video on that. Cohort analysis, I have a video on that. Frequency and value matrix. And then there's all kinds of predictive modeling that you can do. And I have a whole bunch of videos on that topic, right? So for this specific teaching session, we are going to focus primarily on RFM and CLV. So RFM is abbreviation for recency, frequency, and monetary value. Recency is how recent a customer has made a purchase. Was it a long time ago? Was it a couple of days ago, right? So we're going to look at that feature, measure how often a customer makes purchases in a given time period. Again, so that is also important, right? If your customer is interacting with your business quite purchase frequency times. So a little bit similar to RFM, a little bit different though. RFM is recency score plus frequency score plus value score, or amount of money that the customer has spent with us. And CLV measures average purchase value times purchase frequency times customer lifespan. So let's jump into it. I don't actually have any customer data. I looked around the internet, anything satisfactory, so I created a hypothetical scenario here. Now, you probably do have your customer data, your data, okay? Um, that would be extremely weird or just stealing, right? So you have your own customer data. So you just have to understand a couple basic points about this, and you can apply that to solve your own specific problems. I'm just trying to point you in the right direction and show you what needs to be done here. So I created these data frames because I don't have them. You can see here's the head and here's the tail. So the head is the first thing that we see over here, and this is the tail of the data. And if we scroll down a little bit, I have a chart over here. So the distribution here is um, pretty well distributed. It's not really concentrated in any one specific age group, right? It's just spread all over the place. I don't think you even need to do this chart. I just wanted to take a quick peek at the distributions of ages here and see if anything jumps out. It really doesn't. So our customers range from 18 up to 69, and the average purchase value is somewhat consistent. I don't see a whole lot of indication that there's some kind of relationship here. So that's fine. If there's a relationship, we will leverage that and utilize it. Right, I don't see anything here, so we'll just go ahead and move on. So we have our plot. Let's start with the RFM analysis. Okay, I'm making sure that the last purchase date was actually a date. Sometimes these will come to us as strings or text. You can't do any kind of analytics on a string or text, so you have to convert that to some type of date time. And we're looking at the last purchase date, that's the max of the date time, and then subtracting that to get the date in days. That's how we're getting the number of days, okay? And the total spent is going to be the value, okay? And then the purchase frequency is coming from frequency right here, okay? So we're going to bucket these because otherwise these are continuous variables and it's going to be all over the place, right? I just did a video about this like literally 1 hour ago. What does PD cut do and what does pandas cut do. You have two types. There's a Q cut and a cut. I did a video on that, so you can take a look. I think it's very insightful, very informative. This is how we can go ahead and bin or bucket our continuous data into ranges of data sets, so we can do a more effective analysis. It's just a lot easier when you bucket these continuous variables. It's a lot easier to do the analysis on that. Otherwise, it's going to be kind of skewed and kind of messy, just all over the place. So if you have 10 different buckets you're working with, that's great. That's meaningful. That has a purpose, and that's very useful. If you have hundreds and hundreds of different buckets, because all of these scores are unique and discrete variables, that is not going to be super useful for us. So we're going to put those into buckets, and we can see over here we have the recency score, frequency score, and the value score, and that's the money that they spend with us. And then we have the overall RFM score, right? So we're adding these together. 4 plus 4 plus 4 is 12. And then we can segment those customers too. You don't absolutely have to do the segmentation, but you do, if you're looking for this kind of insight, you do have to at least do this separate here to get the RFM score. So I'm looking at the head and the tail of these two data frames. These are the more important customers, so we should interact with them. We should reach out. We should send them opportunities for discounts to go shopping, promotions for items in our store, things like that. These are the high RFM scoring individuals, and we want to take care of these. These are the big spenders, the frequent spenders, and they're spending very recently, right? Here's the recency effect. And these guys down here are not really dropping a lot in our store. They don't come to the store very often. That's the frequency, and they haven't come in a very long time. So these guys, we don't have to pay as much attention to. I don't want to sound like callous or whatever, but really we're focusing on the customers with a high RFM score. If you have a low RFM score, we really can't devote a lot of time and attention to these people. Most likely, you could try to convert them from a low score to a high score, but these people tend to do this all by themselves. So a promotion exclusively for the RFM people would totally make sense. Some kind of discount for these high RFM people, but for these people, we just don't care about that. Okay, I'm sorry. That's tell them like it is. That's all. Okay, so onto the CLV calculation. So we'll say the customer lifespan is 3 in this case. Now again, I made up this data, so I don't have the customer lifespan column. But if you have the first date that the customer was with you, and if the customer is still there, then that lifespan can be way longer than 3 years. But for all these customers, it's probably going to be slightly different. In this case, just to illustrate the point, I'm actually using just the same value. It's just going to be 3. But I think this is pretty realistic. I think a lot of customers will hang around for 2.5, 3 years. In most cases, maybe a little bit longer, maybe a lot longer. In the case of Amazon, for instance, and Microsoft, some of these companies are very brand loyal. They'll be with Microsoft for years and years. They'll be Amazon customers for years and years. So this definitely could be higher, right? In my specific case, I don't have this number, so I made it up, and it is what it is. So let me refresh this. I'm going to sort the data frame and look at the high customer life value, or high customer lifetime value. Okay. Oh, and here we have it. So these are the customers, like the high RFM customers. You want to pay attention to these guys with the high numbers. These guys down here really don't create a lot of value for our enterprise, and that's okay. Okay, it is what it is. We can't really control these customers. If they like us, if they like doing business with us, they'll come back. They will create their own CLV footprint and RFM footprint. We can kind of cater to that a little bit, and we can kind of change this just a little bit by offering discounts and offering maybe free, who knows what, maybe one free item on your next purchase at the store, something like that. So we can kind of cater to these guys, but there's only so much we can actually do. So I just wanted to see how this data looks when you plot it. I created a small loop here. So feature in features, I'm using Plotly. I like this a lot because it's very dynamic and interactive. And I have the first plot here. So this is by gender. So some of these genders are not coming in. It's not a huge number, only 5 here. This is 76 for female and 71 for male. So this is pretty interesting, right? Distribution of income by gender. So we don't have too many people In the high income brackets, when we have too many people in the low income brackets, it's pretty normally distributed. And I think that's what you would see in most places in the United States. Now, I live in New York City, so you tend to see more extremes. You see extreme poverty, extreme wealth. So it probably would not be quite as normally distributed, but in a lot of areas, I think this makes a lot of sense. Here's the distribution by purchase frequency and again by gender. So purchase frequency, somewhat normally distributed. We see 35 and 36 over here, and then on this end, 64, so it's definitely higher, and 50, but it kind of stays within a certain range here. It doesn't really move like this other chart here. Here's a normal bell-shaped distribution. This is a little more flat over here, okay? Just to move on and look at distribution of average purchase by gender. So again, we see like a little dip in the lower areas, average purchase. Okay, so these guys are spending about $20. These guys are spending $200. So you'll see a little bit of activity in the two tails of the chart, but by and large, in the middle, it's kind of flat. When you go over to like 40, 30, we're looking at 30 on the x-axis. Over to here, I'm having 27, 31, and 26 and 36. So again, there's some movement, but it's overall pretty flat. So I'm not going to take you through every one here. Scroll through at your leisure, but I think we answered the questions of how to create insights about your customers using Python, right? So pretty interesting. I had fun putting the code together, testing it, debugging it, creating the results. Hopefully this is useful for you and hopefully it helps you with your own business. Okay, that's it for today, guys. Thank you so much for your time. Enjoy the rest of your day. Bye.